so now that we've developed the concept of opportunity cost, we can talk about comparative advantage, which forms the basis for trade. And now when I say trade, I think people have this tendency to think about international trade, but really the insights that we get from this very basic economic model applies to trade between you and your neighbor, as we have this example from the textbook. Or it's right from a company that's producing something in Cleveland and trading with a company down in Columbus. Right? You don't have to think about this as being on the scale of international trade. Okay? So in this example, here we have that you can either pick apples or pick cherries. Now, if you spend all of your time picking apples, you will pick 20 pounds of apples. If you spend all of your time picking cherries, you'll pick 20 pounds of cherries. Now, your neighbor's more productive. Your neighbor can pick 30 pounds of apples or 60 pounds of cherries. So now, if you just compare directly, right, now if both of you pick apples, your neighbor can produce or pick more apples than you can. So we would say that your neighbor has the absolute advantage in picking apples. Likewise, your neighbor can pick 60 pounds of cherries in the same amount of time that you can pick 20 pounds of cherries. So once again, your neighbor is more productive, so your neighbor also has the absolute advantage in picking cherries. Absolute advantage is determined simply by directly comparing productivity in that activity. Okay? Your neighbor is more productive than you are, both at picking apples and at picking cherries, so she has the absolute advantage in both. We're concerned with the notion of comparative advantage. Comparative advantage is determined by comparing opportunity costs of production. So here we're going to make use of our PPFs. And so to follow the example in the textbook, we are going to put apples up on the y-axis and cherries down on the x-axis. And so let's say that this is your PPF. If it's your PPF, then and we have those two endpoints, we say, well, you can produce or pick 20 pounds of apples or 20 pounds of cherries. And what about your neighbor? So for your neighbor, we know that your neighbor is much more productive. She can pick 30 pounds of apples or 60 pounds of cherries. Okay? So now, remember what we said in the previous video, right? The opportunity cost of picking more cherries, the good on the x-axis, and that's determined by how much of what you're giving up on the y-axis, or graphically speaking, it's the slope of the line. And again, we have these simplified PPFs where we have a constant slope, therefore a constant opportunity cost. So what is the opportunity cost of picking one more pound of cherries? Well, if you notice here, that trade-off is 1 for 1, right? And again, because they're straight lines, it's easy. You can just focus on the two intercepts, right? The two endpoints of the PPF. If I go from 20 apples and 0 cherries to 20 pounds of cherries and 0 pounds of apples, I'm giving up 20 pounds of apples and gaining 20 pounds of cherries. That's a 1 for 1 trade-off. So for you, the opportunity cost of picking more cherries for you is 1. Right? Each additional pound of cherries costs you 1 pound of apples. And we're also going to do the opportunity cost of picking more apples. Right? Likewise, well, imagine now you're going in the other direction, right? If I start off with 20 pounds of cherries and no apples, and I want to switch to making apples, I have to give up 20 pounds of cherries in order to gain 20 pounds of apples, or in other words, again, 20 over 20, which is equal to 1. What about for your neighbor? Now, the opportunity cost of picking cherries for your neighbor, right, if we start off up here where they're producing or picking only apples, so we go from 30 pounds of apples and no cherries down to 60 pounds of cherries and no apples, well, then they're giving up 30 pounds of apples in order to get 60 pounds of cherries. So what does that mean? For each, right, so if we simplify this fraction, that's 1/2. And so for every additional pound of cherries that your neighbor gains when she switches to picking cherries, she's only giving up 1/2 pound of apples. On the flip side, let's say she's currently picking cherries and wants to switch to apples. Well, she's going to have to give up 60 pounds of cherries in order to gain 30 pounds of apples. Again, what you give up divided by what you gain. That's how we find our opportunity cost. So in this case, what do we notice here? Well, your opportunity cost of picking cherries, right, 1 pound of cherries, you have to give up 1 pound of apples. Your neighbor, on the other hand, in order to pick another pound of cherries, only has to give up 1/2 pound of apples. Your neighbor has the lower opportunity cost of picking cherries. Therefore, we conclude that your neighbor has the comparative advantage in picking cherries. On the other hand, your opportunity cost of picking apples is 1 pound of cherries per pound of apples, while your neighbor has to give up 2 pounds of cherries whenever she wants to pick an additional pound of apples. You have the lower opportunity cost of picking apples, so we say that you have the comparative advantage in picking apples. So take a look at this example. Right? We already said that your neighbor is more productive in absolute terms than you are, both in picking apples and cherries. Your neighbor has the absolute advantage in both activities, but you still have a comparative advantage in picking apples. This is a very important insight that we get from this basic economic model, right? One that goes back many decades. Right? You think about the power of this insight, right? Because this tells us that even if you are less productive at everything, you still have a comparative advantage in something. That means that you have something to offer in the economy, right? And likewise, if you're more productive, let's say in this case you're the neighbor, and you're more productive at everything, what we'll be able to show is that you can still gain by specializing in the activity where you have a comparative advantage in trading for the other goods. So for the sake of this example, let's start off with a case where you're not trading with your neighbor at all. You're just picking all the apples and all the cherries you're going to consume. That's an important thing to keep in mind here. Without trade, the only combinations that you can consume are those that are on your PPF, or of course inside of the PPF, but as we already discussed previously, those points are inefficient, right? So you could consume on any point on your PPF because you can produce on any point on your PPF. So let's say that you just decide that what you're going to do is pick 8 pounds of apples and 12 pounds of cherries. Okay? That's what you're going to pick, and that's what you have to consume in that season. Your neighbor, on the other hand, is going to decide to pick 9 pounds of apples and 32 pounds of cherries. Right? So this is what you both have, right? This is your production and your consumption without trade. But what if you both decide that you want to specialize? Okay? So what happens if you specialize? Now, according to Comparative Advantage, you should specialize in picking apples. So you would shift your production up to this point here. Okay? You're now going to produce or pick only apples. Right, so now you're picking 20 apples. And let's say that the trade-off, right, or the exchange rate here is that for every pound of apples, you can get 1.5 pounds of cherries. Now we're taking this exchange rate or this relative price of apples and cherries just as a given in the example. Right? You don't have the information. You would need to figure that out on your own. So I just take that as given in this example. If that's the case, then, well, what can you do? Well, you can start trading, right? I've got 20 pounds of apples. Well, what if I wanted to keep consuming, say, 8 pounds of apples? So if I trade 12 pounds of my apples away, what am I going to get? Well, each one of these 12 pounds, right? So I'm trading down from 20 pounds of apples down to the 8 I was consuming before trade, right? Picking and consuming. And so for those 12 pounds, I'm going to get 12 times 1.5, which is 18. So that would put me up at a point like this, right, or somewhere around here. And what if I wanted to trade away all of my apples? Well, I could take those 20 pounds of apples and trade them for 30. So now, excuse my drawing, I never ever claimed to be an artist. Right, now, you've got the possibility of consuming up to 30 cherries. What's the important thing to notice here? So this line here, this is what we would call our trade line. Right? So I'm going to specialize. I'm going to produce here. I'm going to pick 20 pounds of apples and no cherries. But now I can trade with my neighbor anywhere along this line. And this line, again, is given by taking those 20 pounds of apples and multiplying by that relative price. Right? I get 1.5 pounds of cherries for each pound of apples. Well, our neighbor can do the same thing. Right? Now, from our neighbor's perspective, our neighbor is specializing in picking cherries. So she starts with 60 pounds of cherries. Now, if each pound of apples gets me 1.5 pounds of cherries, that means that 1 pound of cherries gets me how much? Well, it's the inverse of this, right? 1.5 is 3 over 2, or in this case, you flip that and it's 2/3 of a pound of apples. Okay? If 1 pound of apples gets me 1.5 or 3/2 of a pound of cherries, then 1 pound of cherries is getting me 2/3 of a pound of apples. So if I do the same little exercise I did for you, if we do that for your neighbor now, then this 60 goes up to 40. Right? And so if we take the example that we had here, we say, okay, well, if you decide to go from 12 down to 8, you can consume all the way up here. Or, maybe you decide to trade only 10 of your apples. Right? You say, you know what, I like apples. I want to consume more of both. So if I wanted to be, say, at 10 and 10, where would I have ended up in my PPF? I would have ended up with 15 pounds of cherries, right? So I can now pick 20 pounds of apples, keep half of them, trade the other half for 15 pounds of cherries. I've got a combination I could never get before, right? I could never consume 10 pounds of apples and 15 pounds of cherries if I had to pick them all on my own. Okay? At best, at 10 pounds of apples, I would have only been able to pick 10 pounds of cherries. So I'm getting those 15 pounds of cherries from my neighbor. Right? So my neighbor's going down here to, say, 45. And what are they getting for those 15? Well, they're getting the 10 pounds of apples. I did not draw that very well. Put it right here. Right, about 10 pounds of apples. Right about here. Right? Again, what's the important thing to note here? Both you and your neighbor are consuming combinations of cherries and apples that you can never produce on your own. Now, you're consuming at a point outside of your PPF, right? A point that is not attainable on your own. So you can reach higher levels of consumption than you could if you didn't specialize. This is a pretty powerful insight, right? You, even though you had a disadvantage, right? You didn't have an absolute advantage in either picking cherries or apples, but by specializing in apples, you can still have something to trade and be better off by trading with your neighbor. And your neighbor, who's more productive at both activities, still finds it worthwhile to specialize in picking cherries and then trading with you for your apples. And again, this holds when we're talking about countries trading with each other or simply you and your neighbor trading with each other. Very basic, but very powerful insight that we get from this very old economic model.